Welcome and thank you for joining us today for Big Data in Action, Insights Across the Hybrid Enterprise. My name is Raleigh Gould and I'll be your moderator for today's event. Our featured speakers are John Myers, Managing Research Director at Enterprise Management Associates, and Dr. Barry Devlin, Founder and Principal at 9Site Consulting. In his role as Managing Research Director of the Business Intelligence Practice Area, John delivers comprehensive coverage of the BI and data warehouse industry with a focus on database management, data integration, data visualization, and process management solutions. As founder and principal of 9Site Consulting, Barry provides strategic consulting and thought leadership to buyers and vendors of BI solutions. Barry has 30 years of experience in the IT industry, previously with IBM as an architect, consultant, manager, and software evangelist. And before I hand things off to today's featured speakers, I did want today's audience to know that for today's event, we will be taking questions by either using the Q&A panel located in the right-hand column of your screen, or else you can use the Twitter hashtag BigDataSurvey. John and Barry will be monitoring this hashtag for the next several weeks, so please feel free to use it to log any questions you may think of, either during the event or after. Also, today's event is being recorded, and you will receive a follow-up email from Enterprise Management Associates tomorrow that will include the on-demand playback, as well as some new research from John Myers. And now I'd like to go ahead and turn things over to our first featured speaker, John Myers. John?
Well, thank you very much, Raleigh. I appreciate that that introduction. And as you pointed out, we're trying something a little new today, and we'll take questions both on the Q&A panel and we'll take them on Twitter. So if you do watch this as a recording, you have a chance to interact with Barry and I, not necessarily in real time, but you'll get to ask questions later on. Today's research has been sponsored and supported by a number of organizations. Our premium sponsors are both Dell and Platforma, who have done a great job of helping us in terms of the sponsorship of this event. We also have a research sponsor of Teradata, has also been supporting this particular research over the years. In terms of our agenda, we're going to first talk about a bit of the research highlights. Dr. Devlin's going to walk us through those components. I'm going to talk a bit about our respondents, some of the big data projects that are associated with this research, and we're going to talk about some of the drivers of big data. We at EMA and Barry kind of agree that these are 5 drivers that have helped bring big data from where it was a few years ago to something that is evolving, if not on a quarterly basis, then on a monthly basis. And then we're going to talk a little bit about an EMA concept called the Hybrid Data Ecosystem, where we're going to talk about how all these components all fit together. And then at the end of the webinar, we'll do some questions and answers. In terms of our research methodology, EMA has developed a great methodology that allows us to really get some good quality inputs from our end user panelists into what we're doing. We have highly qualified respondents who have visibility into and responsibility for big data initiatives. We have a very nice way of being able to cross-check people's answers and make sure they come through. This survey is global in coverage. We have respondents from North America, Middle East, Europe and Africa, Asia Pacific, and Central and Latin America. So this is truly a global look at how people are handling big data and their projects. It also has balanced inputs from both business stakeholders and technologists. When we're taking a look at the world of big data, and whether it be an operational workload or an analytical workload, it's important for us to have inputs from both business and IT associated with that, so that we can get a sense of how this information is being used. And then again, as I talked about, we're going to get some real-world insights. We're not just going to be talking about strategies or horizontal infrastructure choices, but we're going to be looking at over 1,000 active big data projects. We're going to give you information on business goals, sponsors, the processing workloads, and some of the primary and secondary data sources associated with that. But this gives you a good sense of what the methodology is associated with this research. And now I'm going to hand it over to Dr. Barry Devlin, and he's going to give some information about some of the higher points of the research. Dr. Devlin.
Joan, thank you so very much, and it is a great pleasure to be talking to you from here on a sunny evening in Cape Town, South Africa. Yes, it's my pleasure to give you some of the research highlights. This is actually the third time that Ninesight and the EMA have collaborated on the Big Data Survey. So as you might imagine, we're beginning to see some trends and some similarities as big data goes mainstream. We're also seeing some things that were somewhat surprising, and we'll share some of those, both aspects of that with you. So as I say, big data projects are becoming increasingly commonplace, and we'll go into that in a moment. We also took this opportunity, because it's the third year, to investigate some new terms. We focused on some high-profile terms that have been going around the industry in the last 12 months. Clearly, we could not avoid the Internet of Things, and that was a bit of a surprise because, at least from the point of view of our respondents, the Internet of Things has already arrived, and I'll show you some data on that in a moment. The ideas around data-driven concepts are also going mainstream and are particularly interesting in terms of the way that our respondents are thinking about those going into the future with increased number of users using data-driven approaches. And we also probed into my favorite term, not data lake, and trying to understand where that term is going. And we came to the conclusion that data lakes are being filled. They're being dug and filled as we speak. So let's look a little bit deeper at those different points. First of all, this is a series of data that we have over the past 3 years, and it divides our projects into 3 parts. Those that are in operation, that's to say they're actually in production or they're very close to production, late stages of pilot implementation. In terms of serious planning, those are projects that are in the early stages of piloting, and then we've got investigating. And you can see that over the 3 years, we've had a very big jump between 2012 and 13 in terms of the numbers of projects in operation. But from 2013 to 14, we've had a sort of stabilization there in the operation, in the in-operation numbers. We're going to be delving deeper into this as we dig through the data. But the question, I think, is whether this small percentage drop is statistically significant, or whether it means that there is some pullback, some small pullback in the amount of projects that are actually in operation. The perhaps more interesting trend between 2013 and 14 here is the big move from investigating to serious planning. So essentially those people who were investigating last year, and perhaps more of them, have moved into serious planning. They're really doing pilots, and they're really looking at what they can do in terms of big data. Looking a little bit further, last year we began to think in terms of projects within the organizations as opposed to the number of respondents that we got. So we started asking about individual projects, and I think last year that was the first survey that has ever been done at this level, and I believe we're still continuing that trend this year. Now, looking at the number of projects per organization, we can see that between 2013 and 2014, we have had a significant decrease in the number of organizations who have only 1 or 2 big data projects, and a significant increase in the number of organizations who have 3 or more big data projects. So very clear, big data has gone mainstream, very clear that big data is part of the ongoing process, part of the production process of many organizations around the world. Let's move on to the Internet of Things. Our surprise was this data. Essentially, this data says that among our respondents, the Internet of Things has already arrived. These top 3 bars here, which basically correspond to currently adopted and at different levels of essentialness or importance within the business, these top 3 bars actually mount up to 63% of our respondents saying that they have something to do with the Internet of Things already in operation. So So again, this is something we want to dig a little bit deeper into, and we have some data over 3 years on the next slide, which is this division of data into 3 categories. The 3 categories that we use talk about process-mediated, human-sourced, and machine-generated. And let me explain those terms just briefly. Process-mediated data is data that you and I have known for many, many years. It's the stuff that's in our operational systems, in our data warehouses and data marts. It's completely linked into the business processes of the organization. And you can see over the 3 years that data has remained relatively steady in terms of the percentage of data that exists within our respondent organization. Human source data is everything that comes from people, from Twitter to documents to videos to audio, and it's been the, if you like, the early area of interest in big data. Now, what was interesting that we saw in human-sourced information was a significant drop in that between 2012 and 2013. And I need to tell you where that went. Well, it went to machine-generated data. Machine-generated data is what we're typically now talking about today as the Internet of Things. But, of course, there is machine-generated data which comes from inside the organization. Think of ATMs, think of machines within the systems, think of network computers in telcos, and you have lots of machine generated there. So we saw between 2012 and 2013 a big jump, or big shift, let's say, from human-sourced information to machine-generated data. And that has maintained its, if you like, reasonably steady between 2013 and 2014. Just a point here in passing is that back in 2012, we were actually monitoring this based on the number of the number of respondents. Whereas when we went to 2012 and 2013 and 2014, we were actually doing this in terms of the number of projects. So there's a slight difference in terms of data here, but we think that the trends are significant and worth keeping. So as I'm saying here, the Internet of Things, machine-generated data, is really where we see the growth happening, and it is, I think, pretty well embedded within our environment today already. Let's move to the other 2 areas that I mentioned. Data-driven concepts. Well, this slide is showing us that data-driven concepts are going mainstream. The top 3 bars again show different ways in which it is currently adopted. And again, they total to 62% of our respondents basically in the area of having something adopted within this data-driven area. They're using it, they're beginning to do it. And as I mentioned earlier, we're seeing that as we outlook beyond 2014 and 2015, that people are seeing that more and more of their organizations and people will be using data-driven concepts and techniques to use it, to analyze and to make decisions within the organization. Finally, in the highlights, I just want to talk a little bit about the data lake. I've just chosen in this highlight to show you an industry segmentation of data lake implementation. And again, what you'll see here is that there's a lot of people who are saying that data lake, we call this great data lake, data ponds and data puddles, just to keep us amused. In the great data lake, lots of people who are saying, we've done something, we've implemented something, it's adopted. And you'll see quite significant differences here across the industry segments, with retail really surging ahead with the tsunami of data lake implementation. And with those words, let me hand back to John.
Well, thank you very much, Barry. Appreciate it. Those are some great insights of what we're taking a look at the research. And one of the neat things about this research is we have so much information in here that it was very difficult for us to pick those highlights. but I'm going to give a little bit of information about the respondents who are associated with this research. We have 351 respondents, again, balanced between business and technology leaders from around the world. These folks, again, came from North America, the EMEA marketplace, which includes Europe, Middle East and Africa, Asia Pacific, and Central and Latin America. In terms of the sizes of these organizations that people are being involved with, almost 50% of our respondents come from that large or 500 to 5,000 headcount size of organization, and another 35, 36% come from an enterprise-sized organization. But it's important to note here that we have 15% of our respondents come from a mid-sized organization, or that less than 500 headcount. And a lot of those organizations are going to be the ones that are, they're not just the ones that have a large data center infrastructure and doing these types of things, but a lot of these organizations are taking big data and disrupting marketplaces. While Uber, Netflix, and other types of organizations are no longer at that particular size, they took a particular idea and grew it through a big data strategy and became very disruptive. So it's important to see where those folks are contributing into this research. In terms of what industry are we seeing organizations from our survey here, kind of surprisingly, manufacturing had a big jump up in this year's rankings as our number one primary industry associated with that. We also have significant representation in finance, public services, which is government, legal, nonprofit, things of that nature, and then utilities, which include telecommunications, heat, water, etc. And in terms of utilities, that goes a lot to the helping us manage concepts associated with smart grids, or what Barry was talking about, Internet of Things. How do we get these things together? So two of the major industries associated with Internet of Things is highly represented here in terms of our research. In terms of big data projects, this year we almost doubled the number of projects that we have information upon. We have over 1,000 of them, and it's almost an average of about 3 projects per organization, which shows that, if you go back to that maturity information, kind of shows you that we're right about in the middle, so about half the organizations are above and below, and it gives us a good sense that we're starting to see organizations continue to move forward in terms of not just putting in infrastructure, but putting in these projects that are going to be the implementation of what we're seeing. In terms of the product distribution, as I was saying, we detailed out 1, 2, 3, all the way up over to 10 projects, and our average is right there in the middle between 3 and 4-ish. So it's kind of nice to see these particular pieces. But this gives you a sense of, if you are getting started in your big data initiative, where you might be in terms of the project numbers. We have several that are, well over 10 projects, almost 5% of our respondents, but it gives you a sense of where you can position yourself within this particular distribution. In terms of project goals, what was the end reason for the projects that are associated with it? Market basket analysis, cross-sell, upsell, and social brand management analysis came up big on these lists of big data projects. Our number one project from last year, fraud analysis, liquidity, risk, looking at risk management, is now in our third space. But this also gives you a sense of the distribution of different types of projects that we're seeing associated with these goals. In terms of who's using these projects, in terms of who's the end data consumer, we have over 40% of our respondents are from the business side of the house. So we're seeing line of business executives, we're seeing business analysts, including marketing and finance analysts, who are using these projects so that they can impact the business. The goals, a lot, we're talking about how do we improve our revenues or lower our costs, and now we're seeing that these data consumers are also likewise the end people who are helping to affect organizations from a top-line revenue or bottom-line margin type of approach. Interesting to see in here, data scientists. We hear a lot about data scientists when we talk about big data and other types of concepts. Last year, we saw them at about a 10% adoption here for our end consumers, and here we're about just shy of 13%. So we're starting to see that growth, and I think that goes to the fact that while we always talk about data scientists as being cool things, that sometimes we view them a little bit more as being few and far between, but they are growing and becoming more available to folks in their organizations. Talking a bit about what are some of the drivers of big data. In terms of the overall requirements or drivers of big data, speed of response is a big issue that we've seen, not just in this year's study, but across many years of study. For the second year in a row, our number one use case for big data projects has gone to a speed of response. We have various and sundry ones where we talk about the use of streaming data, we talk about the staging of multi-structured data, but for the last 2 years, our number one response has been that speed of response, or lowering the latency. And this goes to the concept that during the initial stages of big data, organizations were understanding what the data was, where they could collect it from, bringing it together into one place. And over the last 2 years, we've seen organizations have now assimilated what that data can do and have said, okay, this is how we bring in geolocation data and help it to optimize, whether it be from a B2B fleet shipping type of concept or a location-based services type of concept, and bring that really into an operational context in terms of operational processes. Here gives you a good sense about some of the business goals. We've kind of collapsed them down into some segments. But if you look at this, we asked about what is the workload latency associated with these particular projects. And you can see that near real-time latency is very important across all of these different workloads that are associated with these projects. And in fact, when we look at operational analytics, there are more operational analytics projects associated with near real-time result sets than the next category combined. So you can see that making sure that the information that's available to organizations, whether it be operational, analytical, our operational analytics concept here, near real time, or that speed of processing, is very important associated with that. In terms of data loads, one of the first things when we first started getting into this research was how big is big data. And while we're not trying to tell you that if you don't have these numbers, you're not big data, because we have a large set of answer pools that are associated with this, but as we take a look at what we're looking at for a most common response, the size of big data for 2014 is between about 11 and 50 terabytes for our most common response. So I took the highest ranking numbers across several different categories and pulled them together for this. But if we broaden it into more of a majority response, where we look at 50 to 60% of our respondents, we're looking at a range between 5 and about 225 terabytes worth of size. As compared to last year, these numbers are a little bit lower. And I think this shows that we had probably some more of a very large companies involved in our survey from last year. But this gives you a sense of where a big data environment for your organization may or may not be. In fact, 33% of our respondents indicated that between 10 and 20% of their overall data management, so the information that they have in their data center, is associated with big data projects. Into the future, for both 2015 and 2016, we put together some projections, and it's looking like our most common environment is going to be between that 20 and 75 terabyte environment if you're pulling data together. Again, this is an environment where, it's not the petabyte-sized monsters that we generally associate with a big data poster child, some of the ones we hear in the news all the time, but it's definitely a size that's not going to be managed by a shadow IT department. This is information that's going to need to be placed into a data center for professional care and feeding and things of that nature. So we're definitely seeing this kind of moving down this particular path in terms of data load. In terms of economics, big data has been one of the big disruptors in terms of both marketplace economics, if you want to talk about organizations like Netflix, Uber, et cetera, but also in terms of implementation economics, where we're seeing downward price pressures associated with how we're implementing particular big data environments. We asked a question, said, of the funding for your big data projects, who's paying for it? Is it coming strictly from an IT perspective? Are we getting funding from outside? And 41% of our respondents indicated that they were getting non-IT sources of data associated with their big data projects. This is down slightly from last year, and I think this shows that as big data has been maturing, IT is now putting it into their budgets and saying, yes, we recognize that this is a core competency that we need to be associated with, and we're starting to see that. So we're probably going to see over the next couple of years where we're going to see a higher percentage of IT budgets be associated with big data, and we're going to see less of those line of business departments providing direct funding into those projects. In terms of project sponsors, our number one project sponsor, of course, is IT, because we're seeing a lot of that associated with that. But our next three are marketing, sales, and customer care. Organizations that you may not traditionally think that would be associated with a big data technology project, but marketing is interested in how do we do cross-sell, upsell analysis? How do we get information into from that we have inside our organization and help us gain additional sales or share of wallet with our particular customers? In terms of overall sales, we're starting to see organizations talk about how do we bring additional information into our sales process so that we can continue to develop from more of a cold lead type of environment more into how do we target our services. And then customer care. That's an interesting one to see here, where we're starting to see organizations say, let's get a view not just of a particular system, whether it be an order or a customer care platform, but how do we start to bring all of that information together and say, if someone calls into one of our call centers and is having a bad experience, whether it be on our online portal or other particular types of environments, how do we bring that forward and say, address that issue and help find an answer to those customers right here, right now. In terms of workloads, what are the particular tasks that are being assigned to these big data environments? We're not only seeing it be from an analytical perspective, where we saw a lot of the initial concepts associated with big data, but we have it across the board. Our number one workload was associated with operational types of concepts like billing and rating, things of that nature, to generate invoices, to get revenue into the organization. And we're seeing that with a lot of online organizations where they, due to the speed of response associated with a mobile application or an online platform, really needed a different type of implementation that they probably weren't getting from their traditional environments. We're also seeing asset logistics types of optimization type of concepts, where we're taking information that's associated with our projects, bringing it together, and being able to decide how do we maximize the value of this particular resource or asset, or how do we minimize the costs associated with that. So that's a way to take a look at it. And we're also seeing ad hoc and data discovery associated with this, allowing people to have access to this data and find new insights into it. You know, operational and optimization both kind of require a lot of information to be brought together. But when you're in that discovery phase, you're taking a look at what can I find new from this information? What new insights can I glean? How can I create that next new business model that'll help disrupt a particular industry? But we're looking at these platforms having workloads across the board. In terms of data structures, Barry talked about how we've categorized machine-generated, process-mediated, and human-sourced information as being part of the data sources. In that, this year we asked about what are some of the primary and secondary data sources for these individual projects. And it was quite interesting that we saw as one of our number one concepts was bringing in data from across the organization, from those operational platforms, from our data warehouses, things of that nature, to provide that context to the information that we're pulling from machine-generated sources. So understanding which customers, the who associated with this is going to be part of our organization, what products are being associated, what are the locations associated with some of these pieces. So, it's one thing to geocode information or have that be provided from a machine-generated perspective, but how do we put that into the context of, one, where we're doing our business, two, should we be doing business in those particular areas, et cetera. One particular example from the fraud or risk management area is something called velocity analysis. If you make two transactions on opposite ends of the country and you did so in person, that generally trips a flag to say, hey, we no longer, you can't be in New York and LA in the same time frame. Generally, you have to fly for 5 or 6 hours in the middle. But it gives you a sense of being able to put the context around those big data sources associated with those projects, in addition to pulling that machine-generated data associated with that. From these drivers, EMA has developed a concept called the Hybrid Data Ecosystem. When we developed it in 2012, we took these core requirements of load, structure, response, complex workloads, and economics, and said, instead of taking a technological platform and putting it at the center of what we're trying to do, let's put these requirements at the center and allow the platforms that meet those requirements to kind of be around the outside of it. For example, if anyone's ever tried to do particular workloads inside of a Hadoop environment that are much more tailored to what you might see in a traditional enterprise data warehouse, data mart type of environment, it doesn't make much sense to try to shoehorn something into that particular type of environment, much like we wouldn't ask a data warehouse or a data mart to do a lot of text-based analytics and things of that nature, because it simply is much more designed to do much more of accounting or a numerical type of ascension. So that's where we kind of started the hybrid data ecosystem a few years ago. Last year in 2013, we started to add in these concepts like workload, information management. If you have data that's on these multiple platforms, because you've said, hey, it's not just one platform to rule them all, but we're going to start to see multiple platforms in these environments. How do we manage this data around these particular platforms, and how do we manage the particular workloads associated with that? And again, we have data consumers that are now pulling information into these environments. So it's a good way to take a look at how a hybrid data ecosystem in this big data environment is going to meet a lot of these needs. In 2014, we took a look at the question of how or where are organizations implementing these platforms associated with it. In this particular graphic here, bars that tend to the left seem to be a little bit more on-premise data center bare metal type of installations. Bars that trend to the right are going to be options that may be as part of a managed service, might be part of more of a public cloud type of implementation. But this gives you a sense of where organizations are starting to implement these concepts. Data mart and data warehouse still predominantly going to be inside of inside of our data centers. But that doesn't mean that they're not being implemented in the cloud or as part of a managed service. Up to the top level where you're starting to see some of those newer technologies, Hadoop, NoSQL, being much more friendly, or at least as friendly to the cloud type or managed services environment as they are to an on-prem type of implementation. So again, this just gives you a sense that as we take a look at how and where we're implementing, whether it be on-premise data center, public cloud, a hybrid cloud, public cloud, and then a managed service, where's that continuum for these particular platforms? And using this information, we've updated the hybrid data ecosystem once again to talk about how are we seeing these different types of implementation strategies from on-prem to cloud. How are we viewing the latency associated with this? Operational analytics and operational processing require a very real-time type of implementation, whereas analytics and exploration require a less time-sensitive type of latency. But overall, we're seeing the growth of the hybrid data ecosystem and how we're representing it here today. But this gives you a sense of where your organization can start to bring some things together. No organization needs all 5 requirements, but these are going to be some of the drivers that as you start to look at big data, you're going to want to take a look at. The platforms that go around the outside of that are going to be some of the platforms that you're going to bring together in concert. There's no one platform that really gives you everything that you need in a big data environment, but these things working in concert will give you additional information. And then how are you going to be managing the workloads and the information management that goes in between these platforms to serve the data consumers that go around the outside of it? But this gives you a good sense of where your organization can go and how you can draft your big data strategy. In terms of where we go to here, Dr. Devlin and I went over these. I think one of the big keys here are big data is shifting from size, overall petabyte-sized environments where we're storing all of the information all the time, to something that's much more associated with speed and how do we associate it with our particular business models and things of that nature. It's no longer just bring in everything all the time and store it and let's take a look, but it's how do we bring that context? How do we associate it with a business model and make it move forward? As Dr. Devlin talked about, the Internet of Things is real. We dropped it in here. I don't know what to say, dropped. We spent a long time putting together the Internet of Things section in it, but we didn't think we'd see that level of adoption that we saw for this year for Internet of Things. So I think that organizations over the last couple of years have really been taking a look at this ability to say, hey, we have geolocation information from either GPS, smartphones, things of that nature. We're going to integrate that into what we're doing and make it go forward. But I think, as Barry talked about in his section, there's going to be some technical challenges that move forward because even in something such as the automotive industry, if we want to talk about connected car, the way that one manufacturer pulls information or provides information from their vehicles compared to another may be different. You might find them to be similar within a particular group, such as General Motors, Volkswagen, et cetera, but they're going to be different between those particular manufacturing groups, and we're going to probably see some standards leveling over the next couple of years. Another one that's going to be associated with this Internet of Things technical challenges is how do we get the data from where it's generated to where it can be best analyzed? Do we move it to an edge? Do we move it to a middle tier? Do we move it all the way back to our data centers, et cetera? And then something that's near and dear to both Dr. Devlin's and my hearts are data governance. We're going to be able to utilize some of the best practices for data management, data governance, data stewardship that we've had for many years in terms of operational and analytical platforms. We're going to be able to apply those patterns to what we're doing in big data, but not necessarily the exact concepts. So when we look at data quality for big data, it might be different than how we viewed data quality in the early stages of the data warehouse world, but we're still going to be able to use those same ideas, those same types of business rules and concepts, but we're going to need to change them a bit due to the difference in structure, the difference in processing. So data lineage is going to be important. How do we curate data? How do we look at the freshness of data? Things of that nature is going to be important as we move across this particular concept. Barry, I don't know if you have any thoughts on this last slide before we jump to the questions and answers, but I think we are both agreed that these three concepts are very important for where we see the future of big data.
John, I think you've covered it excellently. I think these are the areas where we're really going to have to focus. And I cannot overemphasize, I believe, the importance of governance as we move forward with data lakes, with big data in terms of size, and Internet of Things in terms of speed. These are really going to be key considerations as we go forward.
Okay, fantastic. So next up, I think we're going to hand it back over to Raleigh, and we're going to start jumping into some of the questions that people will have had for us. So Raleigh, I'm going to hand it back to you, and we'll start our Q&A.
Great. Thanks, John. As I mentioned at the start of the event, you can either use WebEx, the right-hand column, to log your questions, or hashtag Big Data Survey. Again, John and Barry will be monitoring that hashtag for the next several weeks. John, let's start off with you. The first question is, would most of big data projects be on public, private, or hybrid cloud? What did you discover in your research?
Well, we've seen a wide range of those. So I think that there's a couple of issues involved there. So when we look at these different cloud types of implementations for big data projects, we're going to see a mix. External data sources is a very important piece as we try to provide not just that internal 360-degree view of customer, product, et cetera, but as we start to branch out and see how do we look at other areas, whether that be social analytics, social data sources, whether that be information from economic drivers, a lot of the economic information that, here in the United States, the Federal Reserve provides. But those areas are going to lean outside of the data center and be in more of a managed service or a public cloud environment. We might see more of our private information associated with our customers in particular being managed much more in either a hardened private cloud environment or in our individual data centers. But it's going to be based on security and a certain amount on risk associated with that. So when we do the fuller report, we'll be able to break it down into greater detail. But I think it really depends on what kinds of data we're looking at. But we are seeing it spread across these multiple platforms into these multiple implementation avenues.
Thanks, John. The next question I'll throw out, and again, for either John or Barry, if you both want to comment, please feel free. The next question is, what type of best practices would you recommend for deployment?
Well, from my particular perspective, Raleigh, I think that best practices associated with deployment are really to take some of our tried and true practices that we've had for many years in terms of governance and utilize them as our initial stage, but to be able to pull back enough and say, no, we're not going to be able to do a syntactic level of data quality implementation that we may have done in the early stages of data warehousing and analytics. We need to look at it much more from a semantic perspective. And then I also think from a big data implementation perspective, organizations are trying those projects, those individual projects, and trying to find the low-hanging fruit. This is something that people do all the time. But starting out with one or two projects, developing the skills that work inside of their organization for them, and then continuing to grow that path down to multiple projects. So it's not that an organization is going to start out and just go, wow, we're into the 10-project phase and continue that path. But Barry, I'd be interested to hear some of your thoughts on where we should go with our best practices for big data.
Yeah, I suppose it will come as no surprise to anybody when I say what you've learned in terms of data warehousing should be, in my view, carried forward widely in the big data area. And I know that is in contrast with some of the advice we get about, keeping data scientists apart from the BI center of competence. But when it comes down to big data, increasingly it's becoming a core part of the business process, a core part of how we run and manage our businesses, and therefore it needs governance, it needs cleanliness, it needs management, it needs all of the things that we worked so hard and long to do in terms of our data warehouse. And to be very blunt, I think the amount of structure and the amount of value that exists in most organizations' data warehouses can be put to very big and very great use in terms of implementing the big data projects. That's not to say that there aren't some differences. Of course there are. But there's a lot of knowledge in the BI Center of Competence, in the business users who have been playing with data in data marts and in spreadsheets, of course, over the years, that we really do need to bring into the field in terms of its use with the big data environment.
Thank you both. The next question, again, I'd be interested in getting both of your feedbacks. It is, where do you see the future of big data?
Barry, I'll let you kick off with that one because I know you have some strong feelings.
Well, thanks, John. I think the future of big data is secure, let's say, for a start, and we're not going to stop doing this. I think we're going to see that it's going to move more into the middle ranges of what sizes, and I think John talked to this during his section. It's not about the petabytes in many cases because most organizations are not there. What we're going to see is going to be in the large numbers of terabytes for many organizations. It's going to fall into the middle ranges. It's going to move, I believe, as we said, from this idea of it's about size to the idea of speed. We're seeing that people want to make decisions fast. They want to react more quickly. They want to predict in real time the likelihood of customer behavior. They want to follow what's going on in terms of events and measures out in the real world. So it moves very much to speed, and I think that's going to be a very big trend in the big data area in the coming year or two.
No, Barry, and I agree with you. I think that one of the future part of it, and we see it in our Internet of Things adoption area, we see it in some of the machine-generated data concepts, is we're going to have access to more and more data sets. So if someone is listening and going, well, wait a minute, I have this thing that says we're going to have connected devices and there's going to be 10 times as many of those as there are people on the planet in the not-too-distant future, but some of the data that's going to come off of those devices is going to be particular to individual use cases. So we'll find that we don't need all the data all the time off of every device. So, for example, I have a heart monitor that's associated with with running and things of that nature. While it collects a lot of data, and it allows me to dig through it, a lot of times all I care about is what is my distance, what is my time, and what is my heart rate at particular points. So that becomes the signal for me as a user of that data or an analyst of that particular information. We're going to be able to see that in connected car. We're going to see that in smart grids, things of that nature, where there's going to be lots of information transiting through this Internet of Things concept. But when we start to store it, when we start to do our analysis on it, I think you're correct. We're going to start to consolidate down on some core concepts for individual areas. But no, I agree with you, and I think that the future of big data is that some people like to say that big data is just going to become data, as if it kind of moves back into where we were, say, maybe 5 years ago. I see the future of big data definitely being in the concept where we are going to pull the regular data or the more of the structured data sources that we had from 5 years ago and bring those into this big data area, and we will still be big data, but we're not going to fall back from the gains that we've made in terms of the ability to use different structures, speed of response, different data loads. We're going to bring the traditional up into this area, and probably in 3 or 4 years we will be talking more in terms of plain data than we are about traditional versus big.
Thanks, John. Can you also discuss some of the key data sources and data types for Internet of Things, strategies, and projects?
Okay. So in terms of those, we saw that a lot of the information that's currently being used for projects associated with Internet of Things is coming off of geolocation. I think that's one of the easiest data sources to really use because it's the one that we have the most distribution of those particular components. So GPS in your smartphone, GPS in your automobile, these all help you to identify, particular concepts, and we're seeing that used. And I hate to use them again, but Uber's done a really good job of utilizing GPS data to revolutionize the personal transportation industry, if you will. We're also seeing organizations pulling it off of different data types or data sources in terms of business office park types of HVAC usage, which if you look at it is some of the biggest expenses associated with a particular organization. And there you're trying to say, hey, we're trying to move down this particular path where we say, instead of keeping all of our offices open at 72 degrees with the lights on from 9 to 5, et cetera, how do we use the connectivity of Internet of Things to allow us to say where we can make reductions in whether it be lighting, heating and cooling, overall cost structure. How do we do that in a smart way so that we can make these environments both pleasant for the people who are using them, but then also say, let's lower our costs associated with that. But I think the geolocation is going to be a big one, and then devices that have direct contact with costs and revenues are going to be other high areas for Internet of Things. Barry, but I'll let you talk a little bit more as well.
Yeah, John, I think you've covered the ones we saw coming up as most important, but I think there are interesting differences between them, particularly if we look at the geolocation stuff, which is sort of inbound and I think carries many privacy concerns. But if you think of more of the HVAC and the more, let's call it, Internet of Things ideas, we're really going to be having to look at security there. So we're going to have very different considerations to play as we see these different types of data becoming available and becoming used. Obviously, we'll be looking into this in more depth in the report. And looking into the areas where there are smaller numbers but growing numbers of usages of particular devices.
Thanks, John and Barry. Barry, let's take one more question and wrap up with you. What are some of the key differences between a data lake and a data warehouse architecture?
Oh, I'm afraid, the interesting thing is, of course, I have this thing about the data lake. I don't like the term at all, but it's interesting that, of course, we found a lot of respondents who are moving towards it. I think the idea of a data lake, which is essentially let's take all of the data and dump it into a large pond, has for me flavors of the old data warehouse build it and they will come approach. Whereas modern data warehousing is very much focused on understanding what the needs are. I think we're now moving into a time frame when we have to balance both of those needs. You can certainly see that it is worthwhile storing much more data than we used to. We can certainly see that there is opportunities to use data that we may have stored that we hadn't thought about using before because now we've got cheap storage and so on. But cheap storage is not the same as low total cost of ownership. So when we look at this idea, we're going to have to trade it off. We're going to build on the idea of there being data warehouse, which is about, I know what I want in there, I understand how to manage it, I understand how to analyze it, and I combine that over the fence, if you like, with the data in a data lake, which is more fluid and which is more flexible and more agile, but is also but which also needs much more attention to, well, what does it mean and where did it come from and is it reliable and so on and so forth. And blending in those two structures, those two architectures, if you like, together, I think is going to be what we're doing over the next couple of years.
And Raleigh, from my perspective in terms of a data lake, I think it's an interesting new architecture that allows us to utilize some of those economically disruptive platforms, whether it be NoSQL, whether it be Hadoop, et cetera, to get some of a wider perspective than we may have seen from some of our previous environments. So, but Barry brings up some very good concepts associated with it. While we did see some people that were using it, we also saw a significant number of folks that were either not planning a data lake implementation or it was at least a year out from being part of what they're trying to do as a part of their organization. So I think we're still a little bit, we have some of the, I don't know if you want to call them haves or have-nots, but we have the people who are convinced, we have the people who are not convinced. But it'd be interesting to see as we look at both deeper into this data that'll be, as I think as everyone can see here on the screen, will be published in late January. And as we look at it as data lakes moving forward, where do we see people taking those advantages of the patterns that we've developed over the years for data warehouses, data marts, et cetera, for our existing analytical environments, and how do we apply it to this new analytical architecture?
Thanks, John and Barry, for that clarification. And I wanted to thank everyone for joining us today. You will be receiving an email from Enterprise Management Associates tomorrow, which will include the on-demand playback and some new research from John. And I also wanted to mention that John will be presenting a webinar on modern analytics on January 29th, and I'd encourage you to investigate that further too. I'll include additional information about that as well in that email. Thanks again for joining us, and enjoy the rest of your day.
Thanks, everybody.